Hello, everybody. Um, Here for another video into our chess engine. Today I wanted to focus on some UI stuff. So in our last few videos, we added a couple features, such as pawn promotion, en passant, castling, and those were kind of tricky things to add in. Um, at this point, we're actually going to take a break from our chess engine.py class and actually move into the main and do some UI stuff. So one of the things that is good is if you weren't able to implement all of the most recent changes with castling, en passant, or pawn promotion, you can actually just jump right into this, and this should work just fine. And I actually think that maybe um, this video should actually go before those other ones, as it will probably make um, the move functions a little bit easier to debug and to test. So yeah, that's just some thoughts, but let's jump into it. So I want to do a few things today. The first thing I want to do is move highlighting, and we've made reference to this, but I think what would be really nice to do, and I can kind of show you that in this other version that I have. And so this is what we're gonna look at today. Is when I click a piece, it's gonna highlight the piece that I selected with one color, and it's going to move, and it's going to highlight the moves that it can make with another color. And that's the idea. And if I click on a different piece, it'll hide the moves. And this actually can be a useful debugging tool because you can see if it like highlights a square that you don't think it should be able to move to, then you know what it's actually thinking. And that's why I said maybe uh, this would be a good thing to do first and foremost. But if it's black's turn, the same idea. If I click a white piece, it goes away, or if I click an empty square, as it deselects. So that's one thing. The other thing you'll notice is the pieces are animated. When I make a move, it actually shows the animation of said move. And then, so that's the other thing we're going to add today. And then the third thing we're going to add in is our end screen for checkmate, which will add some text in. Here, black wins by checkmate. We'll be able to undo the checkmate move, or if the game is over, we'll be able to hit a key. I'm going to make it the R key to reset the board back to the beginning. Now it's white to move, and at any point in time, actually, we could hit the R key to reset the game back to the beginning. So we're going to be adding a few UI features that will make this nice. So that's what's on the agenda for today. So let's start with move highlighting because I think it's a pretty interesting way of doing this, and I also think it's not too hard to implement. So where I'm going to implement this is its own function. I'm just going to create this right underneath our main above draw game state. It doesn't really matter where you put this, but this will highlight the square selected and moves for the piece selected. All right, so let's call this function highlight squares. And we're going to need a couple things. Obviously, we're going to be drawing, so we're going to need reference to the screen. We are going to be referencing the board. So a reference to the game state is useful here. We are also going to be looking at the valid moves to actually show which ones are being highlighted. And then we're also going to need a reference to the square selected. So these 4 parameters are what we need in order to complete this function. All right, so what does it look like when we're highlighting a square? Well, first and foremost, we want to make sure that the square selected is not empty. So there is a square to select, because if there's not, then the user hasn't clicked on anything and we don't need to highlight it. Then this is a coordinate pair, and so we're just gonna give the values R and C to square selected. So now we have a reference to the row and the column that the user has selected. And we're going to make sure that the color that the piece that's being selected, or of the square that's being selected, is equal to white if it's white's turn, or black if it's black's turn. So in other words, we're making sure that they click on their own piece. And so how do we do this? Well, we have to check our board location RC and the color of that square, so 0. And we're going to check to see if this is white, if it's white to move, else black. And this is interesting because we actually have an if statement inside of an if statement. And this syntax might be a little bit weird, but Python's really cool because it can do stuff like this. But essentially, we have a nested if statement. Our first if statement is if it's white to move, then set some variable equal to W. Otherwise, set that variable to black. And then after you have that variable as W or B, then you compare it to RC 0. And so the idea here is pretty straightforward. If you were to not use this notation, you would have to say if white to move, and then inside of that you would have to say if board RC 0 equals W, and then else board RC 0 equals black. So it would be a little bit more than just this nice line of code. But here we're just making sure that the square selected is a piece that can be moved. All right, so first thing we're going to do is we're going to highlight the selected square. And we're going to use a transparency feature in Pygame to do this. So the first thing I'm going to do is I'm going to create a surface. A surface is something in Pygame that you can use to put images onto. In this case, we're just going to put a rectangle shape onto it. And it's going to be equal to in size, square size, comma square size. Notice the double parentheses here. And this is because surface takes a xy in its constructor. And so we need to give it its coordinates xy pair as one parameter. We need that second set of parentheses there. Now we're going to use this set alpha value. And what this does is it gives you a transparency value. You can play around with this to see what looks nice. I found that I like 100. So this is a transparency value. And if this value is 0, then it's transparent completely. And if it's 255, then it's opaque, meaning it's solid. So 100's a little bit more transparent than opaque. Now we've got to pick the color. Well, what color do we want this transparent square to be? I'm just going to pick blue, but again, you can play around with the color, figure out which ones you like, but pick a color for that and set the fill of S, which is our surface, which is our highlighted square, to that. And now all we're going to do is we're going to use our screen variable, which is referencing our Pygame's surface where everything's being drawn on. And we're going to blit the surface S, which is our highlighted square, onto there. Now, where should we, what should we highlight? What are we trying to highlight? Well, we're trying to highlight the square selected. And so if you'll recall from when we were drawing the board down here, we drew the pieces at C times square size, R times square size. And that's the same idea here. We're blitting this surface S to the location C times square size, R times square size. And notice again the second set of parentheses. This is one parameter that we're passing. We're blitting it at that position XY. All right. Now finally, we are going to do, we're going to highlight moves from that square. So not only do we want to highlight the selected square, but we also want to highlight any moves that come from that square. So again, we can go ahead and pick a highlight color. I'm going to use yellow, but you can feel free to pick a different color if you like. And then we're going to say, now think about how we would do this. We want to highlight any move from this selected square. So what I need to do is I need to go through all of the valid moves that the game state has generated. And I need to look at the starting row and the starting column for that move and see if it's equal to my square selected. If the starting row and starting column are equal to the square selected, then the ending row and ending column is the square I should highlight. Hopefully that makes sense. So we're going to just go through all the valid moves, and we're going to check if the start row of that move is equal to R, and the start column of that move is equal to C, then that means that move is starting from our selected square. And so we can simply blit our new colored surface, which is S. I'm using the same surface for both of these, but I've just changed the color of it. And where am I blitting it to? The end row times C, or just, sorry, C times, sorry, end column, not end row. Column first when we're drawing these things, column and then row. This column is indicating our X. Row times move end row. Oh, sorry. Not times R and C. We don't want to do times. Sorry, that would be a mistake. Let me show you what that does. Well, let's just fix it. Not times C. C is just a row or a column value. We want to multiply it by square size because we want to move it. This is our column number we're trying to move. This is our C, I guess, to keep it symmetric. End column times square size. Sorry about that. End row times square size. So like that. And so now it's just a matter of calling this function, and then we're good to go. So there's a couple places we could call this. I think it makes sense to call it from draw game state, because draw game state is responsible for all of it. It already has a reference to game state. We can add a couple in later on. Add in piece highlighting or move suggestions later. So that's what we're adding in now. So I'm going to remove this comment now. Do I want to do it before or after I draw the pieces? This is kind of up to you. If you do it after you draw the pieces, then the pieces will get highlighted. We can actually show both before and after. I think it's better to highlight the squares before drawing the pieces. So here's the problem though right now about adding it in here. Notice I don't have a valid moose, and I also don't have a square selected. All right, simple solution to this. Just add some parameters. We're going to add parameters here. All right, and so now when I call draw game state, I need to add these two parameters, valid moves and square selected. And since they, are the variable names we have up here, so now I've modified these two, so I need to add them up here, valid moves and square selected. All right, so just to show you what this looks like now, we'll run it and then we'll click, and you can see it highlights the squares that we're on. Now I want to show you if we change the order of this, it's going to look a little bit different. And you might prefer this, but I don't really like it. Notice how the highlight goes over top of the piece. So it's maybe a little bit more outstanding as to what piece you're selecting, but I don't particularly care for that. So I'm going to keep it in between drawing the board and drawing the pieces. All right, and that's our highlight squares. Again, pretty straightforward. Not too much to do there. So next up, we're going to work on animating, and I think this is a pretty tricky function, but a lot of fun. And I hope you like this one. I think it's a really interesting function, right? Think about how you want to animate the move, right? So we have this idea where, okay, I want to move this pawn to this square here. It immediately just redraws the image, not being here, and then draws the image here. Basically, what I need to do is I need to slow this down, and I need to look at every single frame that it's going through and draw it and pause there essentially for a brief amount of time to show this animation. And so when I'm animating a move, basically once I do my second click and the move is made, in order to animate it, it's going to go into this position here. I need to erase the piece from its ending square. So basically, if I draw a white rectangle on the end square, that'll get rid of the piece here. And then I have to draw the piece moving just slightly off of its starting square. Then I have to move it just a little bit more, and then a little bit more, and then a little bit more, and so on and so forth until it's at its end row. And we're going to write a function to do this. All right, so I'm going to just do this all the way at the bottom here. So this function will be for animating a move. So it will take a couple parameters we'll need. First and foremost, we will need the move that we're actually animating. We'll need the screen, sorry, the screen that we're moving it on. We'll need a copy of the board so that we can actually draw the board, and we'll need the clock. Now, one thing that I do want to mention is there's other ways of doing this that are a little bit more efficient from a graphical standpoint. We're going to be basically, after we make the move, we're going to be redrawing the entire board and then erasing the piece and redrawing the piece at a new location. And then we're going to redraw the entire board, when really we only really need to redraw like this section that's being animated, each frame. And so if we were worried about the graphics being really intense, we would want to do a more efficient algorithm for this. But because the move animations don't really make that big of a difference, and they're only happening for a very, very brief part of when this program is running, it's not super important to make this that efficient and do that extra work for what it's worth. So uh, let's first and foremost get our colors from here, from draw board, because I need to use these same colors. So I'm going to simply add in global colors. That's going to make this field be global. So whatever we define them in here, that's going to be what they're defined as globally. And again, I could maybe move this to the top, and that might be a better way of doing this. But now I have access to my colors that I can use. Essentially what we're going to need is a couple things. We're going to need a list of coordinates. So this will be the list of coordinates that the animation will move through, a list of row and columns. We will need basically our change in row and change in column, or our delta row, delta column, which I'm going to call dr and dc. So this will be end row minus start row, and dc will be move and column minus move start column. And you'll see why we need these if it's not apparent right away. And then I'm going to do this other field here, which is going to be a frames per square. And this essentially controls the animation speed. So how many frames do you want it to take to move one square? 10 is like a reasonable number that's maybe a little bit on the slow side. So we can play with this number again. So this will be the frames to move one square of an animation. So if I have that many frames per square, then what's my frame count? How many frames am I going to make this animation take? Well, I'm going to make it take basically frames per square times how many squares I'm moving. Well, how many squares am I moving? It's going to be dr plus dc, or the absolute value of those. So my frame count for my total animation is going to be the absolute value of dr plus the absolute value of dc, so the total number of squares I have to move, times my frames per square. And that gives me my frame count. So what I'm going to do first is we're going to generate all the coordinates based on this frame count. And so we're going to say for frame and frame count. And actually, we're going to do a range function here. So we're going to do range of frame count plus 1. And you'll see why we have to add this plus 1. I'll explain it once we write this next line of code. For each frame, what we're going to be looking at is how much does the row move by and how much does the column move by. And we're going to add these to our coordinate list. So for the rows, It doesn't matter what order we do. If we do row or column, it does not matter. I'm gonna do the coordinates in RC notation, not CR. So we're gonna start with the move start row. That's our starting row location, and then we're gonna add to it basically how much our DR changes by. But I'm gonna have to have some sort of a fraction, the ratio of how far through the animation I am. How far through the animation I am is frame divided by frame count. So I'm going to multiply this by frame divided by frame count. And hopefully you can see what this does. Let's take the two end cases where frame is 0 and frame is frame count. So when frame is 0, then this whole thing is 0, and I'm appending basically start row. Then once frame is equal to 1, and let's say frame count, let's say I'm moving 30 squares, or sorry, let's say I'm moving a knight move, so it's 3 squares to move, then that would mean I have 30 frames. So now I'm 1/30th of the way through the animation. So I multiply my change in row by 1/30th, and I add that. And then I multiply it by 2/30ths and 3/30ths, and so on and so forth until I get to 30/30ths, or in other words, I'm at the ending row or ending location. And that's why we need to add the +1. That will actually put us at the end. All right, so what does the end row start column look like? So start column plus DC times frame divided by frame count. So we're using this little ratio here to manipulate our animation. Okay, now I'm going to show you another kind of cool thing here. Basically, after we go through all these, and I guess we don't really need a second for loop here. We could calculate the coordinates as we go, and that would actually be fine. Oh well, we're gonna do it this way, but we could do this with just one for loop as we just go through each of these, but it's fine. Actually, yeah, let's actually do it this way. I was gonna generate all the coordinates first and then loop through all the coordinates, but we should just draw them as we are looping through them. So instead of appending them, let's just actually save this as R, C. So R is start row, C is that. We can get rid of this coordinates field here. And now what we're going to do is we're going to, for each phase or each frame of the animation, we're going to draw the board where you're going to draw all the pieces. So this just draws the state of the board, and it's going to draw the end state of the board. So the end piece is already going to be there. The piece we move is already going to be on its ending square. And so we need to erase the piece moved from its ending square. And so we are going to say, okay, well, what color is its ending square? And if you'll recall from our way we found the color, we did end row plus end column, or the row and the column added together, modded by 2, and that gave us our color. And then our end square, which is going to be a Pygame object here, a Pygame rectangle, is going to be at our end column times square size, end row times square size, and it's going to be square size and length. And so we are going to draw the rectangle on the screen of the given color at the location end square. So this simply erases the piece that we moved from its ending. The next thing we need to do is we need to draw the the captured piece back. If there was a captured piece, we need to draw that captured piece onto the rectangle. Otherwise, it will look like the captured piece is vanished, but we're making the move. So now the captured piece will vanish once the animation completes. So let's see what piece was captured, and if it's not an empty square, then let's blit that image onto our board. And here we actually saved the n square location. This is why we saved it in variable, because we can now reuse it. And then our final piece of this animation is to draw the moving piece. And so here we're going to blit our move.piece moved, and we're going to blit it on to a rectangle at C and R. Now it's C and R. So C times square size, R times square size, and then square size and square size. So that's going to actually put it at its location for whatever frame of the animation we're at. We are going to call display.flip. We need this display.flip inside of here. Otherwise, we won't see it until the final animation. And this will control our frame rates for the animation. So if you want 60 frames per second for the animation, and so if it's a 3 square move, it'll do 30 frames at 60 frames per second. So it'll take half a second to complete this animation. All right, and so we can test this out and just see how it looks, make sure we didn't make any typos, but we can click and, oh, we got to call the function animate move still, so we can't test it yet. So let's go back up to our main, and let's implement in the animate move. Where do I want to do this? Probably right under when we actually make a move. So if a move is made, we can animate the move. What move are we animating? The last move in the move log. So -1 onto the screen with the board and with the Pygame clock. And now we can see we get a nice animation and everything's good. We'll have to fix our bug with undoing and animating, so we'll do that next. But at this point, you should see the animations working correctly. Yeah, so the this we're going to actually fix next. So if you undo a move and it's the last one, then what it's saying is, well, there is no move log, and so we're going to have to you know, fix this a little bit. And the other thing that's weird, if you just to show you another issue that we're going to fix at the same time, is let's say I make 2 moves, but then I undo that. See how it like redid the animation for white after I undid black's move? And that to me is just, that feels a little bit weird. Like why would it, maybe it's showing the last move made. Oh, that's another thing you guys could add in if you wanted to. Add in a highlight for the last move made. So what was the last move made? That could be something that you can try and implement on your own. Just thought of that. But a lot of chess engines will have that. So maybe look at the move log and the last square and highlight those 2 squares, similar to how we did. And you can actually probably do that right from here, since and maybe just pass the move log in as a parameter or something like that. That's how I would do it. Anyway, so we've got this animate move now, but we need to make it work for only whenever we're making a move, not undoing. And there's a little discrepancy here, right? Because in both cases, when we undo a move or when we make a move, we set this move made equal to true, which is where our animate move is. So it makes sense to me to have another animate variable, essentially. Have another variable here. So animate, and this will just be a flag variable for when we should animate a move. And maybe, you know, we could even keep this on as a feature where, you know, maybe the person selects an option where they don't want animations on at all, something like that. Then we could keep that as false. But here, what we're going to do is if it's a move made here in this one, then we're going to set animate to true. And if it's undo move, then we're going to set animate to false. So after move made is set to true in both cases, animate is going to be set to either true or false depending on what's happening. And so in here, what we can do is we can say if move made, and then we can say if animate. So if animate is true, then we're going to animate the move. And if animate's not true, which is in the case of undoing a move, then we will not animate the move. And then we can just set animate to false after we make a move. And that should fix our error that we had, as well as the fact that when we undo a move, it looks good. All right, so that's our second feature now. Our animations are done. There's two more things I want to do. I want to add in a reset board, and then also our text for our end game. Two more UI improvements. Let's start with the resetting board because it's a pretty straightforward one to do. We have this loop happening and handling events. So what we're going to do is we're going to just add in a key event, and let's say you can pick the key that you want, but I'm going to pick the R key. And this will reset the board when R is pressed. And maybe you want to add a little bit more. Maybe the game has to be over and they press R for this to happen. So that you can't just reset a game in the middle of it, but maybe in the middle someone resigns and you want to just restart without having to restart the program. So this is a good feature as long as people know that it's available to use. So you might want to add in some other instructions with this. But from our standpoint, it's also good for debugging because we can go back to the beginning and kind of test out different things with this. Basically, the easiest way to do this is just to completely reinitialize our game state. So we have this game state, and to basically bring it back to the beginning, we're essentially just going to instantiate game state again using our chessengine.gamestate constructor. Then we're just going to reset some of our fields. So we're going to set valid moves back after we reset the game state. We're going to get valid moves. We're going to undo any square selections that the user has made. We're going to undo any player clicks that the user has made. We're going to set these flag variables back to their default values of false and false. And so that's all it is. This is a pretty easy way of resetting our board, and you should be able to actually see. We can make a couple moves into our game, and then okay, I want to restart, so I press the R key, and everything goes back to normal, and it's White's turn. The other thing we can do now is look at a game over. So I want to make this for whenever a checkmate or stalemate is found. Oh, let's set it to false initially. So we want to prevent the user from being able to click if the game is over, because if the game's over and they start clicking, then there's not valid moves to be found, and we basically want them to either undo the last move or we want them to reset. And so we don't want clicks to actually do anything. Or maybe we want to go and launch an analysis of the game where they can look back through and play through the moves of the game or something like that. But that would run a different sort of module. And so here, what we're going to do is we're going to simply add in here, and you, again, depending on how you wanted to handle this, you could really put this if statement at any point in your code. But I'm just going to put it inside of this mouse button handler. And maybe I do still want to use the mouse for a menu or something like that. But basically any of the mouse clicks, I'm going to simply put if not game over, so that they can only handle events if it's not game over. It'll only allow the player to make moves if it's not game over. It'll still let them press the keys. And then down here, we don't have to worry about that game over variable at all. So in our engine, we had a couple of fields that we added for checkmate and stalemate. And these variables, I don't know why I spelled these with capital M's. I'm going to refactor them and rename them lowercase m. Anyway, so we have this checkmate and stalemate, and we're going to, after a move is made, we're going to look at those variables, and we're going to see if it's checkmate or stalemate. And if it is, we're going to set game over to be true or false. Well, we're going to set game over to be true if it's checkmate, and then we're going to draw our ending screen. So after we draw the game state, what we're going to do is we're going to check. If game state is checkmate, then let's set game over to be true. And now we won't be able to play any more moves. Let's also, if it's white to move, then we are going to call a function draw text. And the text we're going to draw is, if it's whites to move, then it's black wins by checkmate. And if it's black to move, then we're going to call the function draw text white wins by checkmate. If it's a stalemate, then the game is also over. And we will draw text stalemate. So we have these three draw functions that we're going to add in. Now, once game over is true, we could also like add that into these functions here, because if I still probably need move made to work, so we could actually undo a move once the game is over and draw the game state. But you could, yeah, it might be good to make like these by game over equals true as well. Otherwise, it is going to be drawing the board every frame while it's paused, and it doesn't really need to be doing that. But it's a little bit unclear as to what the side effects of that might be. Anyway, our draw text function is going to be pretty straightforward, and this will be the last thing we write today. I've got the screen and I've got the text. That's what this function is, and I'm going to go through this pretty fast because I've gone over this idea of Pygame fonts in other videos. Here you create a font object with the type of font you want, the size of the font you want, and then this is whether it's bold and this is whether it's italicized. So I'm going to make it bold, size 32 font. And I've already played with this to figure out what I kind of like as a color scheme. Our text object is going to be use that font and render a text with the given text. So either stalemate, black wins by checkmate, white wins by checkmate. Anti-aliasing, which we're going to put as 0, and then the color. Now I'm going to do something kind of cool with this, because if we just do black or just do white, it doesn't quite show up as nicely. I think it's kind of hard to read it, just because of the checkered background pattern, and it's maybe not clear as to what color you want to use. So I'm actually going to draw 2 of these text strings just slightly offset with 2 different colors, and it'll give like a little bit of a shadowing effect to make it a little bit easier to read. Our text location, where are we blitting this text to, is going to be a rectangle of size 0, 0, width, height. So at location 0, 0 with location, width, and height. Basically the entire size of our window. And we're going to then move it. And then this part is a little bit nuanced here of how we're doing this, but basically we want to move it to half the width, but I then want to just offset it a little bit in terms of that. So I'm going to say text object dot get width divided by 2. So however much the font is, I'm gonna take half the width of the font and subtract that from moving it half the width of the screen. And this is a way to center it. I'm not sure. There might be an easier way to center text on a surface, but I'm not 100% sure of that. So I found that this is a nice way of doing it. Take our text object's height and width, divide it by 2, and that gives us half of the rectangle of that text, and then move it to said location. Okay, so look over that. If that math doesn't make sense, take a look over it again. Now we will blit the text object at the text location, and that's actually all we really need to do with this. And I'll show you what that looks like. So if we do the really bad moves for white that ends in made in 2 moves, we can see black wins by checkmate. So that's not terrible, but you could imagine like if I had a couple black pieces here, that it might be a little bit harder to read that. It's not bad, but and maybe your square colors are a little bit different, so you can play around with that. But a cool little like shadowing effect that I like is if we re-render the text object but with a different color. And I actually like using a gray color here. This actually gives me a shadow type effect. So I'm going to blit the text object at the text location again, but this time I'm just going to offset it very, very slightly. And you'll see that, again, if I do the really bad move, oops, wrong bad move. Did I forget oh, sorry. Of course, text object. Yeah, I don't know. Maybe it's not as easy to read. Maybe the black is easier to read. Maybe I should switch these colors. But you can see the little like shadow effect to the text to make it a little like 3D looking. I'm gonna actually switch the black and gray and make black be the main color and gray be the outline color. Yeah. So it just gives it a little bit of contrast next to the piece here. And so you'll actually be able to read it if there's some black squares underneath it. Something like that. So you can play around with that a little bit and make it look like you want it to. But all right, so we did a lot of UI stuff. I'm just gonna go ahead and hover or scroll through code we added today, just so in case you wanted to look over it. So we added a couple variables up here. We added the animate variable and the game over variable. We added this if not game over into the mouse button down. We added animate equal true here and animate equals false into the undo move. We added our reset function right here. We added the if animate move, and then setting animate to false. We added 2 parameters, valid moves and square selected here. And then we added this game state checkmate and stalemate. If you don't have checkmate and stalemate yet in your engine, then that's fine. You can just leave this part out and just don't do the text part. Here's the highlight squares function. We added a call to highlight squares in the draw game state. And then we made drawboard have global colors. And then finally, here is our animate move function, which is all new, and our draw text function. All right, so at this point, we've got a pretty nicely working two-player engine. And what I'd like to do now is, since we can completely play a game of chess on this thing, I'd like to do a UI, an AI next. So we'll start with a random AI, and then we will implement in a few other features. So I'll show you guys some of the basic ideas behind move trees and things like that. And we'll talk about some of the algorithms and try to implement them, and we'll see how it works. Thanks for tuning in. I hope you enjoyed this video and are enjoying this video series. Have a great day.